Hi there, this is Abhishek, and in this video I will talk about how you can do the modeling on the text data. So this is the third video in this series of text analytics in R, where in the first video I just gave you the introduction of text analytics with some commands about how to get started. Then we talked about how you can go ahead and clean the data and create the document term matrix, which is essential for doing the modeling of data. And now in this third video, we will see how we can really model the data and do the prediction. Alright, so before I go ahead, one quick information for you that if you are interested in learning ClickView, then you can visit my channel Data and Tools from my channel page. Or if you are interested in learning Tableau, then you can visit my channel BIN Programming, where I keep posting the Tableau related videos. So, alright, let me go back to R, and I left you in the last video over here where I showed you that instead of creating the document term matrix step by step by first cleaning the corpus data, SMS corpus data, how you can do this entire piece in just one command. So now the next thing is that we want to evaluate the data that is there in the SMS corpus clean from the perspective of data visualization. And to do that, one of the very nice ways to do or build is a word cloud. So let me go down, and here what we are doing is we are trying to identify from the messages which is there at the top, ham or spam, where we have the raw data, that we want to identify the messages which are spam, so that all of those messages which are related to spam is stored in the spam. And we have given it a cloud that we want to create a word cloud, so we have given a related name spam cloud. Similarly, we have given the name ham cloud, and we are identifying all of the data that is related to ham, that means good messages. After that, the library that we need to take is the word cloud. So let me execute this and execute this, and then the library word cloud. Alright, after this what we can do is just pass the simple command, which is word cloud, provide the SMS underscore corpus underscore clean. So this is the clean data, the corpus that we created over here, SMS underscore clean, by stemming the document, removing the punctuation, removing numbers and everything, so that we have the clean data. And within the clean data, what we are saying is we are passing the ham cloud, that means all of the data which is related to the ham that we identified over here in this command. And we are saying that only pass on or only show the data which is at least there 40 times. So that's the minimum dot frequency. And you can play around with this to look at your word cloud. So let me press Ctrl Enter to really show you it in action. So that's how the word cloud is coming. So what it basically saying that it is a ham cloud, that means it is a word cloud of good messages, and minimum frequency of each word should be 40. That means each of this word has come 40 times, and those words which are displayed large or in bold like this get or can have come really or are really frequent, and that's why their appearance is much more visible and clear. So it gives an idea about those words which are coming very frequent, and the minimum word, like say here in this case money, is coming at least 40 times, or long is coming at least 40 times. So all of those words which have a frequency of at least 40 times is coming in this word cloud, and those whose frequency is large is becoming large in the font size. So that's the idea. Now let me show you the word cloud of spam. Ctrl Enter. So as you can see, the free, call, mobile, text, price, now, all of these words is basically giving us an indication, okay, this is something related to spam, and we can easily identify based on the messages that we get. Alright, now let's build the spam filter using naive Bayes classifier algorithm. So this is the very standard algorithm for doing the text analytics, and first we will definitely going to use it to build the model. And to build the model, the first requirement is partitioning the data into test and training data. So that's what we are doing, partitioning of data over here. So the first thing is we are identifying the labels. So ham or spam training labels by first getting the training data, at least 70% of training data. So you have total 5559 data points, and 4169 basically represents somewhere around 70% of the data points. So we are identifying the labels, training labels, and similarly for test. And next thing is we want to look at the proportion of data, the ham or spam training labels and test labels. So basically to see how the distribution of data is coming between the training and test data. So control enter, and as we can see within the training data you have ham representing 86% and spam representing 13.5%. Let's press control enter for testing data, and as you can see 86% data related to ham and 13% related to spam. So training and test data is pretty similar, and that's a good thing. That's how we should really go ahead and see the distribution of each of the data points which are coming, in this case ham and spam. Next thing is looking basically partitioning the data into training and testing for document term matrix that we created. So for document term matrix we press the control enter for row 1 to 4169, and for test data again similar to this 4170 to 5559. Control enter. Similarly we want the clean training data and clean test data, so you will get to know why in couple of minutes, so just follow along with me. So control enter. Alright, so once we are here we have the training and test data for our labels, for the document term matrix, and for the clean corpus data. Alright, so the next thing is separating the training and testing data into ham and spam, so that only the trained data, what I meant. So this step is basically an optional step, and the reason I created over here just to look at the word cloud for spam or ham data. If you want you can do that, or if you don't want you can avoid this. So the next thing is about finding the frequent terms. So it's about what you want to say is that find me those frequent terms which are at least appearing 5 times, and the idea behind this is that if it is appearing at least 5 times, based on that you will going to look at your training data and see whether those are spam or ham. So let's go ahead and see it in action in next couple of commands. So first thing is find frac terms is the function that you need to pass, and sms underscore dtm underscore train. So this is the object that you created over here, need to pass on, and you are saying that give me only those terms which are appearing at least 5 times. So you control enter, and then if you want to see the length you can use this length command. So for now it's okay for me, and if I want to view some words, so control enter. So these are the words which are at least appearing 5 times in this dtm underscore train. The next thing is basically creating a document term matrix using the frequent words and doing the training and testing data. So earlier we created the dtm underscore train based on the all of the data, and right now we are looking at the frequent words that we have identified over here and then partitioning our data. This will actually help us doing the modeling, tell us those frequent words which are appearing at least 5 times, and based on that how is our modeling working. So what you can do is press control enter. What you are saying is from sms underscore dtm train only give me those data sets where you have the frequent words. Similarly, here in this case, SMS underscore frac underscore word test, you are saying only give me that data set or those columns where you have the frequent words. So press Control Enter. The next thing is assigning the yes or no to these frequent words into the entire data set. So for that, we need to write a custom function, yes or no, to basically say that whether the frequent word is appearing in the entire data set or no. So the command is very simple. You need to specify the function, open the curly braces, specify one object where you are saying that based on the word which is getting passed in this function in the parameter x, if it is greater than 0, then 1, otherwise 0. So it's basically a frequent term. So after this, what you are saying that if it is 1 and 0, then convert it into a factor, or basically whatever value is coming here, convert into a factor where the levels is 0 and 1 based on the if else command over here, and then give it a label as no when it is 0 and yes when it is 1, and return y. We will apply this on the entire data set for the modeling perspective. So finally, we will again create one other training and testing data set and saying that apply the SMS frequent word train and then to, and then yes or no. So basically what you are saying is, look at this particular training data set, SMS frequent word data set, which you I think created above here, over here, based on the frequent words, and you are saying whether the frequent word is present or not. So to is basically saying that applied on columns, and yes or no is basically the function, and wherever it finds the frequent term word, based on that it will assign no or yes, and that is basically going to be a key for our modeling. So the same apply command, you need to do it on test data and create a new data set, SMS underscore test. Specify the earlier frequent word test data on columns, yes or no alignment on each of the word. Finally, you use the library E1071. If you don't have, you can basically use the command install .packages E1071 and press Ctrl Enter, and it will install the library. Since I already have, I will import this, and then I will use the function naive which is part of this library, and specify the training data and then training labels that we earlier created. So Control Enter. So my model is now based on the training data. My model or the classifier is present in the SMS classifier based on the SMS train that we created here, and ham or spam training labels that we created earlier, ham or spam training data based on that. Similarly, we will look at the test data, but by using the predict function. So what we want to do is we want to specify within the predict function the model that is present over here, and then specify the new data, which is nothing but the SMS test over here. Alright, and you press Ctrl Enter, and it will take a couple of minutes because it is looking at each of the SMS test data row, and based on the model classifier it is trying to align the prediction based on that. So since I have a small data set of 5559 rows, it takes somewhere around 15 to 20 seconds to really run the entire command. So be aware when you are really working on a huge data set, because it will take a couple of minutes or hours if the data set is big or you have more, a lot of data to analyze. So as you can see, the command has run, the red icon has gone, and now what I can do is I can see the result here in the table. So let me first remove this prop.table because that is for the proportion. I'll just press enter. So what it is basically saying, based on the SMS classifier that we applied on the SMS test prediction data, you are basically getting, when actually it is ham, you have predicted ham 1202 times. So that is somewhere around, I would say 95-96% time correct. Similarly, in case of spam data, when it is actually spam, you have predicted 154 times spam, and the error is only here 29 and 5. So if I see it in proportion, I can see prop.table and control enter. But this is basically based on the entire data, so that's why it is coming 86%. So I have a better way of presenting it by using the library G models and produce it based on the cross tables. So basically, based on this cross table command, what we have specified is the prediction data over here, and then the test labels, which is nothing but the actual, and other parameter making it false. And what we are saying is give us the labels predicted, which is coming here, and actual, because first we have specified the predicted data set and then the test labels, which is nothing but the actual data set. So here in this case, you can see that 97.6% the accuracy when the actual is ham, then prediction is ham, and then in case of spam, it is again 96.9% correct when it is spam. Or here, if you are looking at, so this is basically a row-wise evaluation, but if you look at the column-wise evaluation, then 99.6% it is correct. In case of spam, it is 84.2% correct. So that's how you can really go ahead and evaluate the results and see it in action. And that, I would say, is really nice way of doing classification with simple commands. The next thing you may want to do is further fine-tune it by adjusting some of the properties of this. For example, one of the property that you can fine-tune is the number of frequent terms, or the modeling, training and testing data about how you want to identify the number of rows or columns you want to give it to training and testing data. Apart from that, in the SMS classifier, you can specify there is one other parameter which is nothing but Laplace, and you can specify it 1. You can look at the help for further information, but I will give you just the basic idea that Laplace is equals to 1. What it is doing, that for example in a SMS, most of the time from the spam messages we get a message like congratulations, you have won the award, and click here to claim it. Similarly, from our friends also, sometimes when we have achieved something, we find the congratulation, hey, congratulations John for winning this prize. So in that case, Laplace 1 is basically saying and to the model that, hey, go deep down and really look at whether that congratulation is really a spam or ham. So that way your model has to do a lot of work in this case because of the parameter fine tuning and produce the model. So let me press Control Enter and create the model, and then SMS, I need to do the prediction. So it will take a couple of seconds. So let me pause the video. Alright, the command has run, and let's put it into a cross table by pressing Control Enter. If I drag it a little bit up to compare the results, so you can see by adjusting the Laplace estimator or the parameter, earlier it was 97.6%, now it is 97.7%, so very minimal improvement. And here in this case, earlier it was 2.4%, now 2.3%, 15.8% and 15.3%. So some improvement in the error that earlier model was doing. Similarly, here in this case, Earlier it was 3.1 and 0.4, so there is no change in spam. So it has done some accuracy, or it has achieved some accuracy in identifying the ham messages in a much better way. As I mentioned, that not every congratulatory message is a spam. So that's pretty much all I have for this video, and in upcoming video I will explore a couple of other approaches to do the modeling on the text analytics data, and tell you a little bit more whether they are good or not. Alright, till then, thank you for watching this video.